the case of a massless pulley which is hanging like this. There is a string which is passing like this, and over here there is a spring constant K, and from the center a mass is hanging. We have slightly pulled this mass and released it. As a result, this mass oscillates like this. We have to find out what is the time period for the oscillations. So first we do is, we displace this body by a small distance y. We know our steps. That is, first is displace the body by a small distance y. Then find its restoring force. Restoring force is equal to mass into acceleration. And if A comes out to be proportional to minus y, this means SHM. If this is SHM, then we can use T is equal to 2 pi y by A. One important thing to remember over here is that this pulley is massless. Had it been some mass, then our approach would have been different. This would have come into angular SHM. Over here, this pulley is massless, and we shall be using the concepts of how we find the time period for the linear SHMs. First is we displace it by a small distance y. As soon as we displace by small distance y, now we are just bothered what are the fresh forces, restoring forces, which come into play to move this body back towards its mean position or back towards its equilibrium position. There are some forces which are acting. Let's say there is some stretch in this when the equilibrium position is there. When we move it further, that extension will still be there, but there will be some addition to that which will create a restoring force. So instead of that is how this equilibrium position has been achieved, let's talk about what are the extra restoring forces which come into play and which try to move the body back towards its equilibrium position. If this block goes by distance y, it means the center also goes by distance y. So this has also gone by y. So if this is y, so it means we need a string over here and we need a string over here. Y is required here, y is required here. So the next requirement of string is y here, 2y. The string cannot extend. So obviously as a result, there is going to be extension of 2y in this spring. If there is an extension of 2y in the spring, as a result, there is a extra tension which is generated in the string is F is equal to Kx, that is K into 2y. So the extra tension which is generated throughout the spring is K into 2y. We also say that is if we draw the force diagram for this, over here is T dash, over here is T, over here is T. So tension in this, always we know, that is through the laws of motion we know, remember very well, that is whenever we draw the force diagram, free body diagram, by encircling it, tension is always outwards. And tension in one string is same. So over here is T, over here is T, and this other string T dash is over here. So over here it is K into 2y, K into 2y, this is a tension, this is a tension, over here let's say is T dash. For this, T dash is here in this direction. We have not drawn mg because earlier also mg was acting, it was balanced by some forces which have been generated because of expansion in this. So over here we have just written T dash because this is the extra restoring force which has come into play. This extra restoring force has been generated because of this extra extension in this. So this T dash is equal to 2ky plus 2ky, 4ky, because this is massless. So upward forces minus downward forces. Otherwise, if you wish to understand, because this is massless, you can say upward forces 4ky, 2ky plus 2ky, 4ky minus T dash is equal to mass into action, because mass is equal to 0. So 4ky comes out of T dash. Similarly, the extra restoring force acting on this, mg had been earlier also acting, but this mg force had been balanced, already been balanced, because there had been some stretch in this spring and there had been some force in this spring that had been balanced. Right now, when we extend it by further by distance y, the extra force which comes into play is T dash. So T dash is equal to 4ky. So we have come till this point. So 4ky is the extra restoring force. So that comes out to be equal to m into a. So a comes out to be 4k upon m into y. This is constant. So acceleration proportional to y. And this is, we say, that is acceleration is in this direction, y is in this direction, opposite directed. So it means acceleration proportional to minus y. It means this is SHM. So T is equal to 2 pi, y by a formula we can use it. So T is equal to 2 pi, y by a is equal to m by 4k. So this is the time period of oscillations in this case.